Hello everyone, my name is Angus McAndrew. Welcome to a mathematical STEM box. I'm a researcher and a lecturer here at the Mathematical Sciences Institute at the Australian National University. The activity that I'd like to show you today is a game called the Boodie Game. This is a game for 2 players, or if you like, you can play it with 2 teams of players, each team deciding what's going to happen. What is a Boodie? Well, let me show you my little friend here, my Boodie friend. This wasn't drawn by me, this was provided to me by a much finer artist than myself. But, step 1 of this game can be, for yourself, draw a fun little Boodie character. The Boodie is a burrowing animal that was once widespread across Australia, but is now somewhat restricted in where it lives. It's classified as near threatened, meaning that it could be in danger of extinction sometime in the future, though currently it is at least more or less stable. So in this game, we are going to play as 2 players. One is a scientist trying to catch a Boodie so that they can check on its maybe health, check that it's progressing well in its environment. The other player will play as the Boodie, which is a perhaps nervous and shy creature. We'll be trying to avoid that. They'll be staying hidden as much as possible. What happens is that there's going to be a series of holes which the Boodie can burrow in. Each day they can move to an adjacent hole, and each day the scientist, not knowing where the Boodie is, can check one hole, one burrow, to see if the Boodie is inside it or not. And the question is simply, can the scientist ever catch the Boodie? All right, let me give you an example. Let's say here, I want to look at a Boodie that's moving in 5 holes. So what I'm going to do is I'm going to use these cups and I'll arrange them in a line of 5. And the Boodie will be moving inside this line of holes, but the scientist won't know where it is. Now, if you don't have a fine Boodie artist, a local Boodie artist, you can use anything you like. You just need something that can be hidden inside something else. So paper cups with, say, a little plastic counter works. This can represent the Boodie. You just need to have a way to hide something in a cup that the other one doesn't know about. So let's say we do the following. The Boodie player will start by secretly choosing one of the holes, and the scientist player won't look. So let's say left hand is going to be the Boodie player and right hand can be the scientist. So right hand is going to close their eyes. They don't know where the Boodie is, and the left-hand player will say, okay, the Boodie will start in a hole. And then left-hand player takes a turn, and the Boodie can move to an adjacent hole. In fact, it has to move. It can never stay still. The Boodie is always on the move. So the left-hand player will, while the right-hand player is not looking, pick up the cup with the Boodie in it, and then move it one to the left or the right, and then re-hide that Boodie in its hole. Right-hand player can now test a hole. They just pick any hole they like and test, is the Boodie in that hole or not? So maybe they look here. The Boodie wasn't there that time. Left-hand player's turn. They pick up the cup with the Boodie in it while the right-hand player is not looking and move it to one of the adjacent cups. Right-hand player's turn, they check again. Maybe this time they check this hole. No Boodie in it. Left-hand player's turn again. They move. They can move either left or right. They can go back to where they came from. They just have to move. They can never stay still. Right-hand player's turn again. They pick a cup. And let's say, oh, how lucky. The right-hand player happened to find the Boodie this time. Is there a strategy here? Is there some way that the right-hand player, the scientist, can be guaranteed to catch the Boodie? Or is there no way to ever find it? Can the Boodie player always evade them? What's going on here? What's the strategy? And how can one player win over the other one? I'm sure you're keen to explore this yourself, test it out, play it against your friends, and see if you can come up with a winning strategy from either side. There are lots of questions and variants that you can come up with. This problem isn't done simply when you've figured this game out. One variant is, what if there were more cups, or more holes, more burrows for the Boodie to hide in? There are other ways to vary it as well. What if there are multiple booties, multiple scientists searching for the booty? I encourage you to explore and try it yourself. Now, if you would like to see how a solution works, I will show you that now. But first, pause the video, try it yourself, and come back if you want to see if your strategy agrees with mine. All right, pause now. All right, have you tested it? Are we back? Let me show you what can happen. So first of all, it turns out the scientist player can always catch the booty, no matter where they are. I won't go through the effort of hiding it now, just imagine them moving around. Here's what the scientist can do. They can start by checking, let's say the holes are numbered. I'll call this one number 1, 2, 3, 4, and 5. The scientist can start by checking hole number 2. So either the booty's there and they win, or maybe the booty's not there. But that's okay. If the booty's not there, they will then test hole number 3. What's going on now? Could the booty be here or not? Well, they could be. If they had started in hole 4, then they would now be in hole 3. They can't be there if they started in hole 2 because you would have found them already and nothing else gets them to 3 straight away. Okay, so either the booty's here or they're not. If they're not, we test hole 4. What could happen now? Well, let's think about what happened. If they were starting in hole 4, they could have gone to hole 5 for the second move and then 4 again, and we would have caught them now. So we've got them cornered there, if that happened. Or they could have started in one of these holes and dodged us. The trick is then to test hole 4 again. 2, 3, 4, 4. Let's imagine all the possibilities. So if they started in hole 1, they could have been behind us the whole way, and then they would have to jump back and avoid us. If they started in hole 2, well, they can't have started in hole 2. We've already ruled that out. We tested hole 2 to begin with. Could they have started in hole 3? Okay, well, they could have gone 4, and then if they went to 5, we would now got them on 4. They would have to have gone this way and hidden somewhere over here. Could they have started in hole 4? Well, no, we've locked out hole 4 completely. If they went to 3 second, we would have caught them. If they went to 5 second, we would have caught them. So what we have shown is that the booty must have started on one of the odd numbered holes. We would have caught them if they were on 2 or 3. Not only that, by going 2, 3, 4, if they started on an odd hole, they would have been on an odd hole now. We've tested 4 again, which means they have to be on an even hole. Specifically, because we've tested 4, they have to be on hole 2. That might be a bit fast. Think about it. Test all the possibilities. Convince yourselves they have to have started on an odd hole, and then because we tested 4 again, they now move from odd to even, and because we've just tested 4, if we haven't caught them, they have to be on hole 2. So now we know exactly where they are, and we can trap them. Because now we test hole 3, they either go to 3 and we get them, or else they go to 1. And once they're on 1, they have to move back to 2. So we get them. So scientists can always catch the booty. It depends on odd and evenness. In mathematics, we call this parity. And this strategy will always allow the farmer to catch the booty. But would this work for different setups, different amounts of booties, different amounts of scientists, different arrangements of holes? Lots to explore, and I hope you have fun doing so. All right, here is an advanced booty challenge for those of you who think you've figured this game out. I'm going to give you a very, very different sort of setup, and this one requires some pretty serious thinking, maybe even some clever mathematics to solve. So we're going to imagine now an extremely industrious booty that has dug not 5, not 6, not 10 holes. They have dug infinitely many holes. Wow, they have an infinite line of holes going in both directions, going on forever. Same situation. The scientist wants to catch the booty. But the way the booty moves is a bit different now. What the booty does is the following. They started in one of those holes. We don't know which hole, they started in one of them. Could be any of those infinitely many holes. They move in the following way. On the first day, they pick a direction and a number of holes. So maybe they pick left and 3. And then every single day, they move in that direction by that amount. They always move the same. So they started in a random hole, we don't know where. They chose a random direction and a random amount of holes to move at a time. And they do that every single day. It's very regular, but we don't know what it is. Given that setup, given a booty in an infinite number of holes, moving in a completely unknown but at least regular way, is it possible for the scientist ever to catch the booty? This one, no hints. Think about it yourself. How would you come up with that? Maybe you can try some variants. There's a simple setup that might make it easier. Think about it and see what you come up with. Good luck, everyone. Hope you enjoy it.